everyone, welcome to my channel. So in this video I'm going to cover the system design question called Design Leetcode or Design OJ. So OJ is Online Judging System. So before we start the real content for today, I would really appreciate that if you can help subscribe this channel because it can help me to grow. So thanks in advance. So let's get started. So design Leetcode. Usually the first step you need to follow is to try to ask some questions with the interviewer to try to define the feature requests. And you need to clarify the non-goals. So regardless how familiar you're with that, you may say that I use Leetcode to prepare the interview. What question can I ask to define this, to do the scoping? So so you still have some questions you need to ask to scope this problem, because you need to define the solid feature request and you need to clarify the non-goals, because it's very different from like designing the UI UX front-end part or the backend service part. So let's say we are focusing on the backend service part. So of course the front-end part is not it's a non-go. So FE, UI, UX, etc. So I would say one core feature request is to show the problem list. So and also when showing the problem list, we also need to have the user submission status for certain problems. Like for example, you have submitted one question and it is accepted, then there should be a mark there by it. So the third one I can think about is I would say we need to be able to like submit the answer and do the judge. So for the judge, let's say if it is accepted, then it's shown as accepted. Otherwise, it needs to be let's say run answer or time limit exceeded exactor, and we need to also be able to show the failed task case to the user. And the next one I would say is the submission history, which user can refer to the submission history for the code that he or she has already submitted before. So those three features I think are core features. There are some other features like the forum. People can do some discussion, have some nice discussion for a certain question somewhere, and also maybe there's some contests, etc. So we are not going to cover about that. So I said that, let's focus on the first three feature requests: show problem list, submission, and judgment, and also show the submission history. So the next part is about constraints analysis. This is also a very important part because this can help you to understand the traffic, about what is the scale of the system, and help you understand the data storage choice, and also help you understand whether it is just a simple toy you're trying to design. Often, usually it doesn't happen very often in the interview. It's mostly about like trying to let you to design a highly scalable distributed system. So first one, let's do some traffic analysis. Let's say how many daily active users do we have? Let's say we have 10 million daily active users. Each active user is going to like say one show query, show query or submission history, submission query or history query. So let's see the QPS here. So 10 million, so 24 hours, 3,600. So let's say this is 10, this is like 1,000, like for the power of this, and then this. So it's mostly about 100 QPS. So let's assume that we have let's assume it's 300 kps for the peak time. That's for each of the query actually. So it's not actually so actually the traffic is not too much, like 300 kps. I mean, depending on the expensiveness of the QPS, I would say if it is submission, then we need to have some compiler which is quite expensive. But if it is show or like submission history, it's quite it will be quite cheap. So for cheap queries, usually we can just have a one normal server to serve the 300 QPS. But for the submission query, it has some compiler stuff which is quite time consuming, so we may need more servers than that. So this is traffic analysis. Let's say the storage part. So let's say storage. So we have, so what data do we have? So we have the user data, we have the problem data. This will be very small, like very small stuff. Maybe let's say we have 5K questions, and also, or just 10K questions here. And we have users, let's say 10 million daily active users. Let's say in total we have 100 million registered users. And also, what do we have? What kind of data do we have? So we also, okay, so we have the submission history. Submission history. So this one, it says like 10 million daily active user. So 10 million per day. So 10 million per day times 365. Let's say 5 years. So 5 years is like 2000. Let's say it's 2000. So 2000 is like 20 million. Sorry, 20 million is trillion. 20 trillion submissions here. So for, let's say the user, I think is not too much. Like for the user is mostly, let's say 1K for the user profile, then 1K is 100 GB for this one. So for this question is like very small, it's ignorable. So let's, for this one, let's say each of the the average each of the submission we are going to use. So let's say we will have like 10K to store that. So I think 10K, yeah, potentially 10K. So if it's 10K, then we are targeting about 200 PB. 200 PB for, so 200 PB for the data storage. I think that's fine. So for the first 5 years, okay, let's say, just want to make sure that I didn't do it wrong. 10 million, 2000, so million and trillion. Okay, it's not, so 10 million. Okay, so it's like gigabytes actually, 200 gigabytes. Because, okay, so million and like 2000, it's like 2 GB. Yeah, so it's 20 is 2 GB, like 20 GB. So 20 GB. Okay, so 20 GB, it's like 200 TB terabytes. Okay, yeah, so it shouldn't be like PB stuff. All right, so 200 terabytes here, not too much. So yeah, so that's the storage part. Let's say some non-functional, let's say availability. What is availability? Let's say we are targeting about 3 nines, 99.9. Like in every year there might be like several minutes of downtime, which is possible. And also scalability. So scalability should be highly scalable. So scalability is high scalable. and also durability. We shouldn't have any data loss. And so availability, scalability, durability, and latency. Let's say what will be the latency for the submission? So I would say show and the history. Let's say for show or history, it would be less than 200 milliseconds for 90% of the queries, and for submission or judgment, it is going to, let's say it is less than 10 seconds for 90% of the queries. Yeah, I think that should make sense. Yeah, so I think that's pretty much it about this part, and let's go to the next part. So the next part is about some high-level design. So high-level design, so, or we call it design overview or overview. So usually it's like a high-level infrastructure overview about that, and also we define like the different components, how the data flow interact between different components, etc. So not to go into the detail about different parts, so it's mostly focused on the high level. So let's say I'm a user, and I'm going to send a HTTP request to the service. So it is going to call DNS to get the IP address. And then first of all, it is going to hit our service. So it is going to hit our load balancer first. So load balancer, then it is going to have our front-end server. So the front-end server is going to do some authentication, authorization stuff. And then it is going to send some RPC requests to the backend server. So, and by the way, that before this backend server, there should be also a load balancer in front of it. And also, the load balancer is going to query data from the database, but usually on top of the database part, there should be a cache there. So that's mostly about the general data flow, I would say. So let's say I'm a user, and let's try to use the different queries and see how many of the services we are going to put in the backend server. So let's say for the problem list, I would say there could be the one is to show a problem list. So this one, it is going to, I'm not sure. So depending on if it is a login or non-login, and I would say one thing I would ask is, do we allow like non-logged in customers to see the problem list, etc. So let's say we only allow like logged in user to see the problem list. So in that case, we definitely need to query the submission history for each of the user. So let's say show the problem list. So the first service is display problem list, or let's say the first service is list problems. So list problems is going to send so I send a GET request to the service, and then send RPC request to the backend server. The backend server is going to query DB where cache return the proto buffer with the problems, and then front-end server is going to return a JSON format, a JSON object to the user and to be shown in the browser. So the first one is like the list problem, and the second one is submit or judgment. So user is going to send a post request to the front-end server, and then similarly, the front-end server is going to send RPC request. So request contains the piece of code in the proto buffer, and then backend server is going to run the compiler stuff, and then it is going to return the judgment result, return to the front-end server, and then return the JSON format to be shown on the user browser, something like that. And then the last one is the submission history. So this is, let's say, first is list problem. Let's say submit. Let's call it list problem. Submit code. Now let's say submission history. So 3 of the services we currently have in general. So let's dive into the different parts more deeply. So if we get the agreement about the high level design, the next part is more about for the interviewer to ask about which part to dive into in a deeper way. So like the deeper dive, or like the detailed design. So let's go through component by component about the design stuff. So okay, just TBD. So let's start with the DB stuff. So for DB, you have, so first of all, what kind of DB are we going to use, and also what kind of data are we storing here? So I would say if it is for user and problem, it's not a big deal to use to use RDBMS. SQL database, I think it's a suitable thing for user and problem. But for submission history, I would say we should use the considering the data scale, we should use like non-SQL for that. So there's really is no preference to use SQL or non-SQL for, let's say we have the problem to use SQL. That is very straightforward, I would say, because it's very small and easily to be handled by a SQL database, and also it has some schema there. Let's say for the user and submission history, let's say we have user and submission history to use non-SQL. So the difference between SQL and non-SQL, I would say this is a very good question to be asked by the interviewer. So SQL and non-SQL, you would say that SQL is like RDBMS, relational database. So it has an ACID feature, and also usually it is used to be stored for some data that is well defined with the schema. And for the non-SQL, it's just key value pair, and due to the nature that it's key value pair, it is highly scalable, easy supporting like the sharding, but due to that, it doesn't support some other features. Like for example, it doesn't support the ACID feature, and there can be some consistency stuff there. But usually when it is usually when you have a lot of the data, to be stored, non-SQL is a better choice, because SQL itself can suffer from like the scalability issue when the data volume get very high. So DB, so problems that we have the SQL. So let's say for the problem, we have a table. It doesn't. Let's say we have like a MySQL, PostgreSQL, etc. So a lot of things. Let's say we use MySQL here. So we have like the so what column do we have? We have the ID, problem ID, like the primary as a primary key, and also we have the title, like the what is that? The description, and also like the task cases, etc. So those are what we are going to store in the problem. And for the non-SQL part, the user summation history, we use non-SQL. Let's say we use Bigtable here. So for Bigtable, we should, let's say we use the row key as the user ID. So user ID, it can be generated by like a unique ID service, or it can simply as simple as like the user's email address or the username, etc. So row key is this, and also we need to define the column families. So for the column family, let's say we have essentially two of them. So we have one is for the info, the user info, like the first, like the profile, user profile, like the first name, last name, etc. So this is defined like a proto buffer. This is like profile proto, and there should be another column family which is for summation history. Let's say it is summations. So submissions, and for this, let's say we have the column family like this. Okay, so the column family is like this. So each column is like submission and the problem ID. And because there is another dimension for Bigtable, which is a timestamp. So the submission history is user ID. So for the corresponding column, we have the problem ID, and we have the for the Bigtable cell, we have the timestamp. So I would say each cell is going to be user ID, which is a row key, and the column is submission, problem ID, and the TS, and then the value key is this, and the value is let's say it is a proto buffer, which is a submission. So it can include, like for example, the piece of the code, the status of the code, the submission, and if it is like a wrong answer, we need to include the failed task case. So that's pretty much it about the table design here. And I would say this is like a very scalable stuff, and also to have a durable system, we need to set the duplication stuff. So usually we need to have like master slave set up. So one master several different slaves for both the SQL database and the non-SQL database. Yeah, so that's mostly that. And for the cache layer, you can just use some traditional map cached. So essentially we need to cache the problem, which the problem sets, which is like very highly used there. Well, for the yeah, so for the cache, we can certainly store like the problem sets and description. But when it's like when there's a query to list the problems, we still so first of all we need to get the problem sets from the cache, and then we still need to query the database, query against the database to get the user's submission history, so that we can do a join in the backend server to 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 get like the list of the problem and the corresponding submission status to be returned to the user. So cache problem should be within the cache. Let's say the user submission history. Since I would say it could also be cacheable. So, for example, if I'm a user, like let's say I have like 10 10 submissions, like I'm a heavy user on this platform, it's better to cache that as well. So we can cache whatever we want to cache, and to help speed up the system and help make the DB load to be lighter. So that's the DB and the cache layer. And let's say for the backend server. So for the list problem stuff, let's say for list problem, first of all, it is going to query against DB, but as I said, the problem sets is going to be within the cache. And also we also need to, okay, so let me write down that. So we are going to query problem list. So this is cache, first cache, and then DB. And then we need to query the user's latest submissions. Let's say so for users latest submissions, it is also first cache and then DB. Yeah, so yeah, that's the list problem stuff. And then after that, we are going to do a merge about the two datasets in the backend server, and then it is going to be returned to the user. And the next thing is the submit code. So for the submit code part, we just send a post request and then further forward to the backend server as a RPC request. So that one, we will need to have the compiler. So it's like compile the code, run against different task cases, and also at the same time we need to make sure that if the thread runs too long, then we need to definitely kill that, because we don't want a like a dead loop to kill our system. So run against the different task cases, and also at the same time kill like the runtime runtime too long threads. So this part it is going to be quite heavy because there is a compiler there, which is going to take a lot of the times there. But in case there's heavy load, we can always add up the servers to make sure that it can satisfy our business requirement. So we don't need to worry about too much about the load here. So that's about the compiler part. So submit code, compile, run against different task cases. If any of the task case just get runs, or we just stop there. And we are going to return the runs or in the corresponding field task cases. Otherwise, we are going to just return accepted. So that's submit code, and the next one, which is submission history. So the submission history based on the user ID, and the problem ID, and we are going to get all of the cells there, and then the submissions there. So it is going to be quite straightforward, and this part is also cacheable. So yeah, so this is mostly about like a DB query. So on the submission history table, via cache potentially. So overall, there isn't too much to worry about the scalability here. But one thing, what I could see is we have the master slave set up here. So let's say if so if I submit, so there could, because we are using master slave, so there could be like eventual consistency, something like that. So if we, let's say if I submit a code and it goes into the submission history, and it got, let's say we have master, let's say we have the master and slave 1 and slave 2. So let's say the submission history, the submission got stored in the got right to the master, of course, and they got duplicated, replicated in slave 1. But if it's not, if it is kind of slow, like maybe there is a cut between, there might be some network cut stuff, so let's say, or maybe slow stuff, and causing that the submission to be not available in slave 2 for, let's say, 10 minutes. And then when we submit it, when we try to query the submission history, if we goes to slave 2 to read the corresponding submission history, then we may not be able to get the full submission history from slave 2. So that's what it's called. That's what it is about what it is about eventual consistency here. So we need to talk about this kind of case with the interviewer. So whether it is acceptable here for this kind of case to happen. And this thing can also happen for the list problem stuff, because we need to join with the user's latest submission history, and we have this master slave set up here, and so this can cause some consistency, potential consistency issue. But it depends on like the business requirement of the system, whether we allow this kind of whether we allow like eventual consistency or strong consistency in the system. So that will be a good discussion to talk with the interviewer. So I would say if we allow eventual consistency, that's totally fine. If we need to have the strong consistency here, I would say we need to definitely care about like the low watermark and the high watermark among different master and slaves. So if it is like strong consistency, we every time we need to just get everything from the below the low watermark instead of getting something from the high watermark there. Yeah, so I think that's pretty much it. Let's say anything else we need to go over here. We have the front end server, back end server, different services we design here. The bottleneck, so list problem, I think very cheap, pretty cheap, and submission history is pretty cheap as well. and also submit code. That would be the most expensive one. We may potentially need to have more servers, custom servers here, but I'm not a compiler guy, so I'm not sure about how expensive it is. Yeah, so other than that, I think we should be in good shape about this system design question. So otherwise, it really depends on where the interior leads you. So for example, we can also talk about like setting up some monitoring stuff, um, and also setting up some monitoring dashboard and the pager to make sure that everything goes well, and being babysitted by the on calls, etc. So yeah, there are a lot of other stuff to talk about. It depends on where the interviewer leads you to there. So but we are in good overall. We are in good shape understanding the question and how we are going to solve this. So that's it for this system design question. So if you have any question about this design, feel free to leave some comments below. So if you like this video, please help us subscribe this channel. I'll see you next time. Thanks for watching.